If you think I'm going to run all over this town to get my radio fixed, you've got another thing coming. I'll go where I can get it fixed while they're working on my car.
Trouble, boss?
Trouble? You said it. There goes the third customer I lost this week. All because they think we run a radio shop.
Well, maybe they're right. Actually, there's a lot of radio troubleshooting a mechanic can do, Walt.
Okay, next radio customer to come in, you'll get.
Hey, what's going on? I thought you worked around here.
I do, Tech. This is a test setup for checking radio tests. 5 years in the Army, you got to learn something besides saluting.
Hello, Tech. You're just in time to lend a hand. I've got a radio job for Paul.
What seems to be the trouble, Walt?
One of our best customers brought his car in a few minutes ago with a radio that's deader than a mackerel. You think you and Tech can revive it?
Could be, Walt. Checking a dead radio is a lot like following a road. Every so far, there's a fork in the road. You have to be able to read the signs or you're not going to get where you want to go.
Yeah, say that's right. You either find the trouble or you go on to the next intersection, right?
That's right, Walt. How soon you find the trouble will, of course, depend on the cause. Let's take a look at this radio, Paul.
Right, Tech. Well, right where the car is sitting seems to be a quiet spot. So the ignition key turned to the accessory or the on position and the radio volume control on. Listen for the vibrator hum. There. Hear that? The vibrator's working okay.
Well, what if this, what did you call it, this vibrator hadn't hummed?
Well, that would have meant that the trouble was in the vibrator, or in the A lead, which furnishes power for the set.
Why don't you show Walt how easy it is to check that A lead, Paul? It's easier to get at than the vibrator.
Right you are, Tech. First, I'd take the fuse out and inspect it. Even if it looked all right, I'd replace it, because you can't always tell whether it's good or not.
And be sure and use a 14-amp fuse. Higher capacity ones can cause a lot of damage to the set.
Good point, Tech. Then I'd inspect the fuse holder and remove any corrosion I found on the contact. Now, after replacing the fuse, I'd make a careful check of the A lead for damage and make sure that the A lead was connected tightly to the accessory post of the ignition switch.
That A lead might be connected to the hot post of the fuel gauge, Paul.
Well, yeah, but there's a direct wire from the fuel gauge to the accessory terminal of the ignition switch, so it really doesn't make any difference which terminal it's connected to. While I had the A lead out, I'd examine the end that's connected to the radio to make sure it was clean and making a good contact.
And if the A lead circuit checked out okay, it would mean that the vibrator was at fault, so you'd replace it.
And now, let's get back to the radio in this car. Remember, the vibrator on this set works okay, but the set still won't play.
Well, what about the antenna? Could that be the trouble?
Yes, it could. Wait a minute till I get the antenna off my bench, and we'll check this one. Well, here we are. We can make a check in a few seconds by using this antenna we know is okay in place of the one already on the car. So let's pull out the plug on this old antenna and plug in this one. Tune in a local station, will you, Walt? Vibrator hums, but the radio still doesn't play. Well, the antenna and the circuit are okay.
Well, that means we gotta pull the set out of the car to check the tube.
Let's hook this set into my test setup here. All you need is a fully charged battery, an A lead, an antenna, and some ground wire. I'll connect this negative lead from the battery to the A lead socket of the radio and plug the antenna lead into the antenna socket of the radio. Hold on a minute. Before we start checking for faulty tubes, we better check that control unit power cable to see if it's seated properly in its socket.
And be sure the radio is off when you're touching them cable connections.
Right you are, Tech. Now let's turn the set on and check the tubes. First, we look to see if they all light.
Or you can feel them. It shouldn't take over a couple of minutes to warm them up. And it isn't a bad idea to wiggle them tubes to make sure they're tight in their sockets.
Good point, Tech. If the touch and sight test doesn't turn up the trouble, we start substituting new tubes, one at a time. Well, that one's okay. Let's try this one. How's that? Hit it that time.
Hey, you're all right, Paul. Maybe you can tell me what's wrong with the radio in my wife's car.
Maybe. What happens when you turn it on?
Well, the fuse blows. I stick in a new one, and bluey, it blows too, even before she starts the engine.
Sounds like vibrator trouble. Walt, try this trick. Pull these two halves of the fuse holder back so that the contacts are exposed and flash them together like you'd strike a match.
Well, don't hold them contacts together, or you're apt to burn up the internal circuit of the set.
What does this flashing do, Paul?
It sends a surge of electricity through the points and breaks them apart. Of course, if this flashing doesn't do the job, you'll have to replace the vibrator.
You can't miss the vibrator, Walt. It's the only unit with 4 pins.
Paul, what's the story on the vibrator?
Well, to start off, the vibrator has a set of vibrating tungsten points, a lot like the points on a generator regulator. When these points vibrate, they change 6-volt direct current to a pulsating current and feed it through the various circuits of the set. But if those points stick together, more than 14 amps will enter the fuse and it'll blow. And they'll keep blowing as long as those points are stuck.
What about a case where the fuse blows in, say, a couple of hours or maybe even a couple of months apart? Is that caused by the vibrator, too?
In the majority of cases, yes.
A lot of mechanics will blame the generator and the generator regulator for vibrator failures and blown fuses. We'd better set them straight, Paul.
Right, Tech. Actually, there's only about 1 chance in 1,000 that the generator or generator regulator will cause radio trouble.
So don't go playing with that regulator, thinking you're going to cure radio troubles.
And here's another thing that you want to remember, Paul. If you have to send a radio out for service, give the radio service station a good description of how the set acts. This will save time and give your radio customers quicker service.
Right, Walt. Suppose we put this radio back in the car, and I'll show you some of the things to watch to make sure you get the best reception out of the set. Proper installation and adjustment of a radio will go a long ways toward ensuring good reception. Now, here are a few things to watch. Check to make sure these antenna mounting screws are tight and make a good electrical connection.
Right, my boy. A good ground for the antenna is mighty important if you want good reception.
Good point, Tech. And speaking of good reception, make sure the antenna lead is as far up in the cowl as possible, away from other wire. If you aren't careful how you run that antenna lead, you're apt to pick up interference directly from the car wiring. Now, plug the A-lead securely into the radio.
And make sure that there's a 14-amp fuse in the fuse holder.
Good point. And now, the other end of the A-lead is connected to the accessory post of the ignition switch. You want to make sure that the radio is snug in its mounting by checking all attaching screws, bolts, and braces. Then, when you get the push-button adjustment checked and the antenna compensator adjustment checked, you're all done.
Say, when you get this job buttoned up, how about checking the set in that car over in the corner? The owner said something about it being noisy.
Noisy, huh? Sure, I'll take a look at it.
Before you start that job, Paul, somebody better turn the record over.
Before we get into this particular noise job, Walt, I think we ought to talk about common causes of noise, which radio men call interference.
Okay, Paul, go ahead.
Well, there are 3 general types of interference complaints, Walt. External, or the type that comes from streetcars, buses, power lines. Internal interference, which includes ignition and generator noises, and may even include tire static. And then there is interference from background noises, which you get when you tune in a weak or distant station with the volume up high. Now, let's take these one at a time.
There are a couple of things you want to find out from the owner first, Paul.
Say that's right. You want to find out the kind of noise the owner is objecting to, under what conditions he gets this noise, and, if possible, have him turn on the radio and demonstrate this noise.
This external noise, there isn't much you can do about it, is there?
Well, there are some things you can do. You can make sure the push-button tuning adjustment is okay. Here's what you do. You bring in a station with a push-button, then dial the same station manually. If this manual tuning reduces the interference, you'll have to accurately readjust the push-button until you get the same clear reception. If a customer still believes the noise is in the set itself, you can take a ride with him into a different locality and check the variations in interference. This will usually convince him that the interference is external and is due to some local disturbance. Now let's take a look at the set in this car. 8-tube set. Start her up and turn on the radio, will you, Walt? Good. Now listen. Hear that? Now turn off the ignition, Walt. Noise is gone, isn't it? You know what it was?
Sounded like the generator.
Right on the head, Walt. And there are several things you might do to eliminate this generator interference. In the first place, check to make sure that the generator condenser is in place and that both the condenser attaching screw and the generator A terminal nut are tight.
Right, my boy. And if those checks don't turn up the trouble, put on a new condenser.
What about the generator itself, Paul?
Well, if the new condenser doesn't stop the noise, you'll have to check the generator. That means removing the generator band and inspecting the brushes and commutator. Replace any worn brushes and clean the commutator if necessary.
Any abnormal arcing of the brushes means that the brushes aren't seated right.
Good point, Tech. The brushes should be sanded so they'll make good contact. I'll take care of this generator noise, Walt, if you want me to.
Sure, go ahead. I'll handle it with the customer.
Okay. Well, this brings us to ignition interference. Just a minute, and I'll show you this condition.
How do you like that guy, Walt? He makes his own conditions.
Okay, Walt. Start her up again and turn on the radio. You hear that? That's ignition noise.
And that means there's ignition trouble somewhere?
Right, Walt. Actually, all that I did was loosen the wire at the high-tension terminal of the coil. A loose high-tension wire is probably the most common cause of ignition interference. You can usually correct this type of interference noise by making certain that you have a good electrical connection at the high-tension terminal of the coil, a good connection at the coil and spark plug wire terminals of the distributor cap, and a good connection at each of the spark plugs.
And make sure the porcelain on them plugs is clean. You don't want none of your spark jumping down the outside of the plug.
Of course, if a quick check of the secondary wiring doesn't uncover the interference, you'll have to check out the complete ignition system to find the trouble.
Ever run into tire static, Paul?
Oh, that's an off and on condition, Tech. You seldom get tire static on wet days because the static charges that build up in a car and in the tires are discharged to the pavement as fast as they build up. But on dry days, on concrete or blacktop roads, this static will not be discharged as fast and may cause radio interference. You can test for this condition by driving the car at both high and low speeds over a dry blacktop or concrete road. If you get objectionable interference, drive the car down a dirt or gravel road. If the noise disappears, you'll know it was tire static.
Whenever you run into this tire static interference, inject some tire static suppression powder into the tires with a special injector.
We might mention the background noises you get when you tune in a weak or distant station. You usually get this noise when you turn up the volume in order to pull the station in. Since your radio doesn't know the difference between a weak signal and man-made static, it amplifies both the signal and the static. Actually, there isn't too much you can do about it. Now, Walt, after the interference noises were taken care of, I'd check the tuning of the set. We'll let this set warm up before we make any adjustments, and I'll show you a step-by-step story on that. Okay, Walt, I'll extend the antenna if you'll tune in a station with a manual control around 1200.
Remember, this is an 8-tube set, Walt. The tuning is a little different than on a 6-tube set.
Right you are, Tech. The 6-tube set has a manual antenna compensator only, while the 8-tube set has a manual and a push-button antenna compensator.
Whoa, back up a minute. What's an antenna compensator?
An antenna compensator is a unit which makes it possible to adjust the installed set to the antenna. On this 8-tube set, you select the 5 best stations in your area for electric push-button tuning. They must fall within certain kilocycle ranges, of course.
And you can find a chart showing this range in the reference book.
First, pull off the 5-station push-button covers. These are the 5 buttons in the middle. Now, manually tune in a station near 1200 and push in the number 5 button. Then tune the push-button knob to bring the station in clearly, the station you just tuned manually. We picked number 5 button because the electric push-button antenna compensation is made with this button pushed in and the station tuned in clearly.
And now you're ready to make the antenna compensation adjustment. Right, Paul?
Right, Tech. Now I turn the push-button antenna compensator to get maximum volume on this station. Then adjust each of the 4 remaining push buttons to the desired station.
The instructions for adjusting a 6-tube set are in the reference book.
Say, that sure sounds mighty sweet now, Paul. It just goes to show what a good job of tuning can do for a radio set.
And that ain't all. It shows that us mechanics can do a good job of radio troubleshooting. Besides proper installation and tuning, we can track down interference noises and replace faulty tubes and vibrators. But remember, don't start taking a radio apart. That's a job for the radio service station. And now I gotta go. I'll see you next month.
So long,
Tech.